Good evening, everyone. Our topic is recent development in 5G standardization, presented by Ishraq and Yuki. So this is our outline. We will introduce these aspects in detail later. So in order to adapt to the exploding amount of information, new and more device applications and demand of huge data, 5G is urgently needed in the future of 5G era. So we will realize more flexible, reliable, and intelligent user services. The fourth generation communication technology is we are using now, and it is a technology product that integrates 3G and WLAN and can transmit high quality video images. The fifth generation of mobile communication technology have been divided into two categories. First is mobile internet and Internet of Things. 5G presents low latency, high reliability, and low power consumption. It is no longer a single wireless access technology, but a comprehensive solution for a variety of new wireless access technology and existing wireless access technologies. So the 5G conception is divided into two parts. It is short for 5G generation mobile communication technology, and it is an extension for 4G telecommunication communication technology.
So what are the uses of fifth generation technology? With the exponential growth of mobile devices, the need of fast connectivity grows as well. 5G will provide us with the increased bandwidth for those devices to be connected for ultimate user mobility. 5G will also provide services with low latency, which will enable better mobile technologies for business and consumers. High-speed data transfer of 5G will enhance the video streaming, downloading data, gaming, and other mobile experiences. 5G telecommunication services are also expected to enhance interconnectivity in between smart devices, for example, self-driving vehicles and smart homes.
The ITU defined three typical use cases in IMT 2020. MMTC, which is massive machine type communications, EMBB, which is enhanced mobile broadband, and URLLC, which is ultra reliable and low latency communications. So MMTC mainly reflects between objects and objects, communication needs for smart cities, environmental monitoring, intelligent agriculture, and so on. So URLLC applications have extremely high requirements for time delay and reliability. It is mainly for the special application requirements of Internet of Things. So the EMBB is mainly to pursue the ultimate communication experiences between people. Corresponding to high traffic mobile broadband services such as 3G high quality videos, it is not only meet the requirements of continuous wide area coverage, but also meets the high capacity requirements of densely cities. The future technology trends have been investigated. Basically, bands above 6 GHz are ideal for IMT 2020. In the last quarter of 2019, ITUR will accept one or several of these for IMT 2020. The deployment of IMT 2020 network will occur during 2020. The 5G standard is mainly completed by ITU and 3GPP. It is led by ITU, and 3GPP is mainly focused to the specific design implementations of technical standards and specifications. The IEEE engaged in area regarding wireless areas, including cloud Wi-Fi and something. The ITU finalized determine the 5G standardization work. The solution through the 5G conference will be submitted to ITU for ruling, and then the ITU will give the final solution. The goal of 3GPP is to define a full system that includes radio access network and call network.
As illustrated in the diagram, the specification of the core part of the network of Phase 1 shall be finished by September 2018, and the specification of the core part of the Phase 2 shall be completed by December 2019. As declared in 3GPP workshop, the timeline will also meet the expectations of ITUR requirements. Both the ITU and 3GPP have identified a 5G timeline. The ITUR 5G standard plan is divided into three phases. The first phase is the pre-standardization study, and the second phase is the research phase of technical requirements and assessment methods, and the third phase is the candidate solution collection, assessment, and standardization of work.
So as we mentioned before, the first phase of the period before 2015 World Radio Conferences, the focus is on completing the 5G micro description, and the second phase is from 2016 to the end of 2017, which is a technical preparation phase. And the third phase is the phase in which candidate technologies are collected. From the end of 2017, the ITU will organize assessments of candidate technologies received, organize technical discussions, and strive to reach worldwide consensus. By the end of 2020, the ITU will release a formal 5G standard. So the first version of R5 is non-standard alone new radio specification. It has been derived in late 2017. And the second R5, R15 version is standalone, which was released in June 2018. And R16 is planned to be finished at the end of 2019. So in long standalone 5G version, the most important deployment need for EMBB has been established. After that, full standalone 5G support with 5G core is finished in June 2018. And some specifications for potential migration options are determined between July 2018 and December 2018. So R16 is focused on 5G expansion and efficiency. Some key features for 5G expansion like 5G vehicle will be implemented in this period. So both 5G and IEEE 802.11ax can achieve high data rate. Both of them consume a lot of power of good coverage, and both of them trying to enter each other's field. The most significant difference is they use different spectrums. A lot of new technologies are used in 5G radio access network and core network. In RAN, movie, wave, spectrum sharing, carrier aggregation is used. In CN, SDN, which is software defined network slicing are used. So CRAN use fiber front-end to connect baseband units and remote radio units. The RRU converts optical signal and radio waves into each other's form, while the BBU is responsible for implementing all features of the base station and interfering with the core network. The advantages are it does not need a large space to be installed, it does not require the high amount of energy, and also does not need air conditioning. So NFV is concept proposed by Carrier Alliance. The key feature is to deploy of network devices function from network hardware. As the innovative architecture in network, SDN has the following salient features. It has separation of control and forwarding functions, centralized control, can use widely defined software interfaces. 5G network will be able to provide multiple services, which means it can support very different services to guests with very different requirements.
As we can see in the spectrum allocation diagram, almost all mobile devices resides in the frequency band of under 6 GHz, but as the number of mobile users are increasing exponentially, the frequency bands are getting overcrowded. This overcrowding results in drop of calls, slower connections, and speeds. In year 2015, telecommunication companies started to look for answers for these problems, and millimeter wave was the answer. Recently, researchers have found a way to mitigate the problem of millimeter wave being absorbed too easily, since it is of very high frequency, is by introducing small cells. Multiple small cells will be densely put together in a site, typically in dense cities, to relay the signals in which will enable the wave to travel further and faster. What is spectrum sharing? In urban areas, 5G will depend on small size densely allocated cells which will share the exact frequency used in other areas by another dense network setup. 5G will be able to use these spectrum bands efficiently by different sharing techniques. For example, TV white spaces, licensed shared access, and spectrum access systems. The radio access network used by 5G will utilize the power of massive MIMO by implementing them in a micro-assisted small cell switch will utilize the lower bands to provide omnidirectional traffic through a control panel. Use of millimeter wave bands is also very essential in 5G because at this frequency the arrays can contain hundreds of elements easily. One of the most essential use of MIMO is to increase the capacity of 5G quite remarkably. The efficiency of frequency usage is upgraded using spatial multiplexing. The propagational loss is also eradicated by the use of beamforming technology when operating in high frequencies. 5G intends to use exponentially high frequency bands from a range of legacy frequency to to as high millimeter wave bands, which can be up to 100 gigahertz. But frequency bands and this high is not going to be available by 2020, and hence the target is limited. 3GPP has held a meeting on September 2015, where they have decided to implement frequency bands of 6 gigahertz for 5G use. There's a lot of factors which will affect the deployment of 5G, and one of the most important factors affecting the 5G deployment of 5G is the international standards of spectrum management. The availability of equipment is also a huge concern of 5G as well. The equipment and devices will need to be of a certain standard around the world for easy deployment of 5G organizations like 3GPP and United Nations telecommunications. There's other technical difficulties such as 5G not only puts like high demand on the network speed but also puts forward higher requirements in terms of access density, network delay, and network reliability. In this sense shows that we need to modify from the architecture aspect. How to make changes and achieve these goals obviously requires a technical breakthrough. In addition, 5G also puts in new requirements on security performances, for example, the security requirements of functional virtualization, network slicing, and multiple wireless accesses. With 5G rises a lot of security concerns, and since 5G is a technology which is still under research and development, there are many security gaps which are not addressed yet. And recently research has shown that 5G has enhanced cloud usage and that data will be susceptible to security risk. And the interconnectivity of devices will also make it highly risky for any kind of hacking to occur. Fatal consequences can occur in a breach made by a criminal organization as well. Countries like USA is building their own 5G system from ground up to avoid security issues as such. Recently, studies shows that China has spent more than $24 billion, more than US, in building 350,000 cell sites, and US on other hand has built around 30,000 in the same time frame from 2015. South Korea has also invested a lot in the mid-band frequencies and high-band frequencies to be implemented in 5G. A simulation for real-time 5G was implemented by a company named Docomo in the early 2012. They used the ray tracing machines to analyze 5G, and it shows tremendous increase in capacity than today's conventional LTE, which will enable users to gain speeds up to 1 Gbps. That will be all. Thank you.